Well, welcome. In this video, we're going to be looking more at the unit circle. We've talked a little bit about the unit circle in some previous lessons, but in this one, we're going to start to see how the unit circle starts to take shape as far as coming up with some of these specific values that you're going to have to memorize, and you're going to have to know these exact values for upcoming quizzes and tests. So let's figure out, well, how do we go about finding some of these values? We're going to start out by looking at values in quadrant 1. We're going to be looking at the 30, 45, and 60 degree angles to try to figure out what those values are. And we can use, once we figure out those values, we can use those values to find the other values of our unit circle. But let's start by looking at those basic values, the 30, the 45, and the 60.
Okay, well, you may recall from geometry that we have these two special right triangles. The first of which is the 30, 60, 90 right triangle. And any triangle that's a 30, 60, 90 right triangle has a special relationship between the three sides. Now recall that the hypotenuse is the side across from the right angle. And then the triangle is made up of two legs. In this case, we have a short leg and a long leg. Now the relationship between the sides is that the short leg is always going to be just a simple value of n. And the hypotenuse for a 30, 60, 90 triangle is always going to be twice that. So if I know that the short leg is 6 units, the hypotenuse is going to be twice that. It would be 12 units. And the relationship for the long leg is it's the value for n times the square root of 3. So if n is 6, the long leg would be 6 times the square root of 3. Well, let's look at how we can use this to come up with some values for our unit circle. So now, the reason why we're working with this particular right triangle is remember that in a unit circle, if I want to find a point on that on the circle, I can use that point to create a right triangle. And that's essentially what we're doing here. We're using a 30, 60, 90 triangle. And if you notice, on that unit circle, the radius is the same as the hypotenuse. So for right now, for this problem, the hypotenuse, the 2n, would be the same as the radius in our unit circle. Now in our unit circle, the radius is always going to be 1. So I want to figure out what would n have to be in this scenario to have a value of 1, because we want the radius, or then the hypotenuse here, to be equal to 1. So to figure out what n would have to be, I divide both sides by 2, and I get n is 1/2. And sure enough, if I take 2 times 1/2, I get my radius, or my hypotenuse here, is 1. That means my short leg here is going to be 1/2, and that means my long leg here would be 1/2 of the square root of 3, or square root of 3 over 2 would be a better way to write that. Now also recall that the sine of an angle equals the opposite over the hypotenuse. So if I want to figure out what the sine of 30 degrees is, I'm going to take the opposite leg, which is the 1/2, over the hypotenuse, which is 1. Well, 1/2 divided by 1 is just 1/2. To find the cosine of an angle, the cosine of an angle is the adjacent over the hypotenuse, so the adjacent leg over the hypotenuse. The adjacent leg for the 30 degree angle is going to be the square root of 3 over 2. We're going to divide that by the hypotenuse, which is 1. So the square root of 3 over 2 divided by 1 is just square root of 3 over 2. So in other words, the sine of 30 degrees, the exact value is 1/2, and the cosine of 30 degrees, the exact value would be square root of 3 over 2. This is the kind of things that you have to have memorized from the unit circle. Let's look at sine of 60 and cosine of 60. Well, remember, the sine is the opposite over the hypotenuse. Well, now, since I'm looking at my 60 degree angle down here, the opposite leg is the square root of 3 over 2. The hypotenuse is still 1, so when I take square root of 3 divided by 2 over 1, I get square root of 3 over 2. And the cosine of 60 degrees is going to be 1/2, because, again, the adjacent leg would be the side that's 1/2, and the hypotenuse would be 1, and 1/2 divided by 1 would just be 1/2. So that's how we find the sine and cosine of our 30 and 60 degree angles. Well, now let's look at how to find the sine and cosine of a 45 degree angle. Well, recall that we also have in geometry this special right triangle for a 45, 45, 90. And the relationship between the sides is that in this case here, it's an isosceles triangle, so these two legs are going to be the same. So we'll call those n. And the hypotenuse is going to be longer by the square root of 2. So it'd be n times the square root of 2 would give us the hypotenuse. Now this is going to be a little bit trickier, but the concept is the same. I still want to figure out what my hypotenuse would be, or what my value for n would be to get a hypotenuse equal to 1. There's a little bit more work here because I want to get the n by itself, so I divide both sides by the square root of 2. That gives me 1 divided by the square root of 2. But it's improper to leave a square root in the denominator, so we rationalize the denominator by multiplying the numerator and denominator by the square root of 2. So that gives me my value for n would be, well, square root of 2 times square root of 2 in the denominator is just 2, and 1 square root of 2 would just be square root of 2. So my value for n here is going to be square root of 2 over 2. So I know that for these two sides. And if I take square root of 2 over 2 times the square root of 2, well, the numerator, square root of 2 times square root of 2 would be 2. Divide that by 2, we end up getting 1, which is what we want. So now I can find the sine and cosine. You can see here that when I take the opposite of 45 degrees over the hypotenuse, I'm going to get square root of 2 over 2. And same thing with the cosine of 45 degrees. Now here's something to recognize, that the 45 degrees is always going to be square root of 2 over 2. And so anytime we have an angle measurement that's ending in 5, like let's say if I ask you to find the cosine of 135 degrees, well, 135 degrees ends in 5, so it's going to be in the form of square root of 2 over 2. And 135 degrees is between 90 and 180, meaning it's going to be in quadrant 2. In quadrant 2, x is negative. So the cosine of 135 degrees would be a negative square root of 2 over 2. So again, just remember that anytime the angle measurement that ends in 5, it's going to be a form of square root of 2 over 2. You just have to figure out if it's positive or negative. Let's see how we can use this information now to find the tangents of these angles. So we're going to find the tangent. We're going to start by finding the tangent of 30 degrees. So let's try that one together. Recall, though, that the tangent of an angle is equal to the sine of an angle divided by the cosine of the angle. So for this one, the tangent of 30 degrees would be the same as the sine of 30 degrees, which is 1/2, divided by the cosine of 30 degrees, which is square root of 3 over 2. Well, we can't leave it like this. This was really ugly. We can never have a fraction inside of another fraction. So we have to simplify this. It's a very simple process once you know what to do. All we have to do is take the numerator, 1/2, times the reciprocal of the denominator, which would be 2 over square root of 3. Now what's going to happen is the 2's would cancel out, leaving us with 1 over the square root of 3. Multiply the top and bottom by square root of 3, and we get square root of 3 over 3. So the tangent of 30 degrees is simply the square root of 3 over 3. The tangent of 45 degrees is going to be a little bit easier because, remember, sine of the angle over the cosine of the angle. Well, for 45 degrees, they're both square root of 2 over 2. And you should recognize that anytime we're taking and dividing the top and bottom by the same number, your answer is always 1. So the tangent of 45 degrees is 1. Why don't you guys try the tangent of 60 degrees on your own? So why don't you pause the video and hit play to see if you have the correct answer. Okay, you should have gotten square root of 3 as your answer. The way that you do that, remember the sine of 60 degrees is square root of 3 over 2. The cosine of 60 degrees is 1/2. When you divide those, remember we can't leave it as a fraction, so we take the reciprocal of the denominator. The reciprocal of 1/2 is 2 over 1. The 2's cancel out, leaving us with square root of 3 over 1, or just square root of 3. Well, this is focusing right now on quadrant 1. Well, how do we find the values of some of the other major angles, the angles that we have to memorize in the other quadrants? Well, that's what we're going to be looking at here. Let's look at the cosine of 120 degrees. We're going to be using, to find some of these values, we're going to be using some of the rules that we talked about in the previous lesson. So if you haven't had a chance to watch that video, you want to make sure you do that for lesson 4.3. So for this first one, for cosine of 120 degrees, for this one we're going to use the supplements theorem. So if you recall from the supplements theorem, we can look at this as being the cosine of 180 minus 60, because 180 minus 60 would give me 120 degrees. And the supplements theorem tells us that the cosine of 180 minus theta equals the opposite the cosine of theta. So in other words, this would be the opposite of the cosine of 60 degrees. Well, recall that the cosine of 60 degrees is 1/2, so the cosine of 120 degrees is negative 1/2. We could do the same thing for the cosine of 150 degrees. We can also use the law of, or the supplements theorem. And to do that, we would take the cosine of 180 minus 30 in this case would give us 150. Well, that's going to again equal the opposite of the cosine of 30 degrees. Well, recall from what we just did in the previous page that the cosine of the cosine of 30 degrees would be square root of 3 over 2. So this is going to be the opposite of that. So this will be the negative, or the opposite, square root of 3 over 2. Now, as far as what you have to have memorized for when we have a timed unit circle quiz, there's not going to be a question involving radians. But you still need to know how to find the cosine of pi over 4, because for the quiz that is not timed, you will be asked to find the solution for a question similar to this one. So the one thing to remember is that pi is the same as 180, so 1/4 of that, or 180 divided by 4, is the same as 45 degrees. So this is the same as them asking for the cosine of a 45-degree angle, which that's one of the easy ones. That's just square root of 2 over 2. Let's look down at letter D here. Letter D says a sine of negative 30 degrees. Well, for this one, we're going to use the opposites theorem. The opposites theorem tells us that the sine of negative theta, or in this case negative 30 degrees, is going to be the opposite sine of theta, or the opposite sine of 30 degrees. Well, again, 30 degrees was 1/2, so that means a sine of negative 30 degrees is a negative 1/2. And then for the sine of negative 180 degrees, well, recall from the unit circle that the negative 180 degree rotation should be right here, and that's at the point negative 1, 0. So the sine of negative 180 degrees is going to be 0. And lastly, this is supposed to read 2 pi over 3. I think my notes had 2 pi over 4, but that was a typo. And this should be letter F. So what we're going to do here is we're going to find, well, how many degrees would this be? Well, 2 pi is 360 degrees. 360 divided by 3 would be 120 degrees. This is the same as them asking for a 120-degree angle. Again, we could use the cosine, or the supplements theorem. So we're going to take look at this as the cosine of 180 minus 60 would give us 120 degrees. So that's going to be the opposite. Oops, I'm sorry. This is the sine. So it's going to be the sine of 180 minus 60. So for that, it's going to stay the same. It's going to be the sine of 60 degrees. And the sine of 60 degrees was square root of 3 over 2. So your answer here would just be square root of 3 over 2. Let's look now at tangents for some of these. For this first one, the tangent of pi over 6, when it's in radians, again, you want to first convert it to degrees. So this would be the same as 180 divided by 6, or 30 degrees. And recall that the tangent would be the sine of 30 divided by the cosine of 30, which, this is the one that we did on the other side. We end up getting square root of 3 over 3. So that would be your answer for letter A. For letter B here, this would be the tangent of, again, pi over 4 is the same as 45 degrees. And remember, we just did that one as well. Square root of 2 over 2 would just be equal to 1. And tangent of pi over 3 is the same as 60 degrees, and that's the one that you did earlier. So that's going to be the same as square root of 3. Just want to make sure, again, that you know how to convert from radians to degrees and be able to find out those values. Now, on this next page, I'm going to have a diagram of the unit circle. If you have my notes, you can print out this blank unit circle. And you're going to want to fill this out. First off, these are the first 2 quadrants. And you might want to fill it out using different colors, because having the different colors will help keep this organized. Because if you notice, a 30-degree, a point on the circle that's a 30-degree rotation. That point, if we reflect it over the y-axis, is going to be the same as a 150-degree rotation. The only difference is that the x value, since we're reflecting it over the y-axis, the x values are going to be opposites of each other, but the y values stay the same. Same thing with the 45 degrees. Reflect that over the y-axis, and that gets you to be 135 degrees. So again, they're the same values, only the x values are going to be the opposites. So it's negative square root of 2 over 2 for the x, or the cosine of 135 degrees, and the y stays the same. So the sine of 135 degrees would be square root of 2 over 2. The radians you don't have to have memorized, but it's good to see those. Again, this is quadrants 1 and 2, so you might want to pause the video so you can fill out your unit circle. And here's the rest of it. Or we can view the whole thing. Make this a little smaller, I guess. There we go. So there you can see the whole thing, so we can see how everything is related to each other. So make sure that you have these memorized. Again, on the unit circle quiz, on the timed quiz, I'm going to ask you questions like, what's the cosine of 315 degrees? And you're going to have to know that that's going to be the square root of 2 over 2. Or if I ask you, what's the sine of 270 degrees, you'd have to know that that's negative 1. Or if I ask you for the cosine of 120 degrees, you're going to have to know that that's negative 1/2. So you want to have these memorized so you can make your own flashcards, or I've provided flashcards for you through the program Quizlet. So go ahead and make sure that you have this filled out. Make sure that you have this memorized, and good luck now as you work on your assignment.